All right, let me just double check, make sure everybody turned in their quiz. Yes. Katie, were you able to grade your homework from last night too?
Yes, ma'am.
Okay, awesome. All right, so you've already turned in your quiz. Go ahead and pull out the last quiz for chapter 10. It was just over 10.5, and let's go over that quiz. Hopefully that'll be a help to you guys. Here we go. Number 1. So it's all over special types factoring and factoring it completely. So here we go. We've got a cubed b minus 4a squared b squared minus 5ab cubed. Sierra, what's the first thing you always do when you're factoring? First thing you ask yourself.
Factor out anything?
Yes. Is there anything I can factor out of all of these? What is it?
A and a B.
A and a B. There we go. So pull out that a and a b, and I'm left with a squared minus 4ab minus 5b squared. All right, let's see here. I look at that first term and that last term, and I ask myself, are these perfect squares? Yeah. No, they're not. So I can't, this won't be a perfect square trinomial. All right, well then the next thing I have to do is go old school. I gotta try to factor this. So multiply the first coefficient times the last coefficient, a times 2, which is 1 times -5, that's -5. And then my b value is -4. So what factor of -5 will give me -4? Oops. There. What factors will give me a -4? Well, 1 minus 5. So I come down here and I break this up. Let's see, let me let Harley in. I'm going to break this up. So a squared, we're going to do plus 1ab minus 5ab minus 5b squared. So I broke up that middle term, b, into 1ab minus 5ab, and then I'm going to regroup them. So a squared plus ab plus -5ab minus b squared. All of that needs to be multiplied by ab, which is what I factored out at the beginning. Can't forget that. All right, I can pull an a out of this first guy, and if I do that, I'm left with a plus b. So again, I factored out an a. And here I can pull out a -5 and a b. So I pulled out a -5b, and I'm left with a plus b here. Again, all of this is being multiplied by ab. I can factor out an a plus b from each piece, and then I'm left with a minus 5b times AB. So here's your final answer. Can't do any more factoring after that. AB times A plus B times A minus 5B. Harley, we are just going over the quiz. Quiz 3 over section 5. All right, let's do number 2. X to the 4th minus y to the 4th. Well, check out both of these. Can I take the square root of x to the 4th? What about y to the 4th? The square root of x to the 4th, what times itself 2 times will get me x to the 4th? Well, x squared times x squared, that's x to the 4th. Same for y squared. So yes, I can take the square root of both of these, which means these are the difference of 2 perfect squares. If that's the case, that looks like a squared minus b squared, so my answer is going to be a minus b, a plus b in this form right here. Therefore, my answer will be, let's see, I just want a minus b, so if x to the 4th represents a squared, then just a would be the square root of x to the fourth, which is x squared minus y squared, x squared plus y squared. But I'm not done yet because look at this piece right here. Is that the difference of two perfect squares? Well, can I take the square root of x squared? Yeah. Can I take the square root of y squared? Yes. So I can simplify, I can factor this guy even more. So x squared minus y squared, it's in the same form. This is like saying it's a squared minus b squared, so therefore my factored answer is going to be in this form. So this will factor to x minus y, x plus y. I can't factor this one because that's a plus sign. I can only factor it when it's the difference, when we're subtracting it. So x squared plus y squared stays the same. So this is my original binomial factored completely. Number 3, a times a plus b plus d times b plus c. Hopefully you saw that. Hopefully you saw that there was a b plus c factor in each one of these, and so we're just going to pull that out. And I pull out a b plus c, and I'm left with a plus d, and that is your final answer for number 3. Number 4, y cubed minus y squared minus 4y plus 4. First thing you always ask yourself is, can I pull out a common factor between all 4 of these? Well, no. So what do? Well, I can, since this is not a trinomial, it's a polynomial, 4 terms, I'm going to regroup these together. So I'm going to put y cubed minus y squared together, and then I'm going to put negative 4y and positive 4 together. Now I can pull out a y squared from both of these terms, and I'm left with y minus 1. So again, how do you check that? Distribute that y squared to the y and to the negative 1. It should be y cubed minus y squared, and it is. And then I can pull out a negative 4 here. So negative 4, and I'm left with y minus 1 as well too. Okay, so now I can factor out of y minus 1 from both of these terms, and I'm left with y squared minus 4. But again, I have to ask myself, is there anything else that can factor? And yes, there is. So let me pull it up here. This is y minus 1 times y squared minus 4. This is the difference of two perfect squares. So a subtraction sign, is y squared and 4 both perfect squares? Yes, they are. And again, it's in the form a squared minus b squared. So it's going to equal a minus b times a plus b. So y minus 1, I can't factor that anymore, but y squared minus 4 can factor as y minus 2. Remember, this got to take the square root, y plus 2. So that's my final answer for number 4. And number 5, AB plus 2B minus 12A minus 24. Ask yourself, is there a common factor that I can pull out of all 4 of them? Nope. So let's regroup them. I'm going to put AB and 2B together, and negative 12A and negative 24 together. Now I can factor out a B from both of these terms, and then I'm left with A plus 2. I can pull out a negative 12 from both of these, so pull out that negative 12. I'm left with A plus 2. Again, factor out an A plus 2, and I'm left with B minus 12. Can I factor that anymore? Nope. So that's my final answer for number 5. And number 6, x squared plus 2x plus 1 minus y squared minus 4y plus 4. Okay, let's take a look at these ones separately. So let's focus on this one right here. Well, is this the let's see, is this a perfect trinomial? Remember, I asked look at the first term and the last term. Are those perfect squares? Yes, I can take the square root of x squared. I can take the square root of 1. So multiply those two terms together and take the square root of it. What do you get? X. Multiply that by 2, and that's 2x, which is my middle term. So yes, this is a perfect square trinomial, which means I can factor it in the form. So this is a squared plus 2ab plus b squared. So I can factor it in the form a plus b squared. What's my a value? Well, a squared is x squared, so just a is x, and b is 1 squared, square root. So this is this factored, all right? Now let's take a look at this one right here. Now I've got a subtraction and a plus sign. This looks like it may be the form a squared minus 2ab plus b squared, and if that's the case, we can factor it as a minus b squared. Let's check. First and last terms, yep, those are perfect squares, so multiply those together and take the square root. I get 2y, multiply that by 2, that's 4y. That is my middle term. So yes, this is going to be a perfect trinomial, which means I can factor it a minus b. So let's see here, that's x plus 1 squared, which was this first trinomial factored, minus the second trinomial factored is going to be y minus 2 squared. All right, so I've got x plus 1 squared minus y minus 2 squared. I'm going to come up here and I'm going to erase some of this. We need a little bit more room to work. All right, you're halfway there. Because notice, I've got x plus 1 squared minus the whole value y minus 2 squared. This is one whole value. This is one whole value. So this is actually the difference of two perfect squares. My a value is represented as x plus 1. My b value is represented as y minus 2. So therefore, if I have the difference of two perfect squares, I can factor that into a minus b times a plus 1. So here we go. X plus 1 squared, that represents a squared, but in my final answer, I just want a, so you take the square root of x plus 1 squared, which is just x plus 1. So I have x plus 1 minus, so this is my a value, a minus b, same here, a minus b, so there's my first piece right here, there's my a minus b value, times, again, a plus b, so x plus 1 plus y minus 2. All right, once you get to this point, the only thing left to do now is just to simplify. So remove all the parentheses. Now I have x plus 1, distribute that negative, minus y plus 2 times x plus 1 plus y minus 2. Can I simplify anything inside the parentheses? Yes, I have like terms, 1 and 2. So this is x plus y plus 3. And this is 1 minus 2. So this is x plus y minus 1. So this right here is my final answer. All right, that last one was probably a little more tricky. All right, any questions on the quiz before you have to go? Or any questions on homework? Chapter review, y'all are supposed to grade those. And I saw that y'all did. So questions on the chapter review. Sierra, I know you told me you missed a couple. Give me one of the ones that you missed.
Number 22.
Okay, let's do number 22 real quick. We've got a squared minus 22a plus 121. Okay, what's the first thing I asked myself, Sierra?
If you can factor anything out.
And can you?
No.
Nope. Okay, what's the next thing you ask yourself?
I don't know, but I know you have to multiply the first and last term.
Okay, well, that is one of the ways that we have learned, but remember our little shortcuts that we started learning? This is a trinomial. Let's see if it's a perfect square trinomial. So, can you take the square root of the first and the last term?
Yes.
Ooh, okay, well, let's do that. Take the square root, multiply the first and the last terms together, and get the square root. What do you get?
11a.
Multiply that by 2 and you'll get 22a, and that is your middle term. So yes, this is a perfect square trinomial, which means, how can I factor this? What's it going to look like?
A minus 11 squared.
You got it. This is a negative, a minus, and a plus, so we're going to have a minus b, all of that squared. This is your b value. Excuse me, this is your b squared value. This is your a squared value, so we have to take the square root to put it in the form a minus b squared. Good. All right. Harley, give me one.
Number 40.
Okay. I've got x to the fourth plus 6x squared plus 9. Okay, what's the first thing you ask yourself, Harley?
If there's anything that can factor.
Can you pull anything out of all three of these terms?
No.
Nope. All right, so then what's the next thing? This one's similar to what we just did with Sierra. Is this a perfect square trinomial?
Yeah.
Okay, so if it's a perfect square trinomial, you should be able to take the square root of x to the fourth and the square root of 9. So what is the square root of x to the fourth times 9?
X squared times 3.
There you go, 3x squared. Multiply that by 2 then, and it should be the middle term. Yes, it is. So this is a perfect square trinomial. I can factor this very easily then. It's going to be, what do you get inside here?
3. Yeah.
Start with your a value. So this represents a squared. This represents b squared. So what would just a be? If a squared equals x to the fourth, then a would be what?
X squared.
X squared. So you want your a value. What sign goes in here?
And addition.
Yes, because we're plus and plus. And what's your b value?
3.
There we go. X squared plus 3 squared. Can I factor x squared plus 3 squared anymore?
Yeah. No.
Can you?
No.
What's your rule? What does it have to be? In order to factor a binomial like this, what does this sign have to be?
Negative.
It has to be the difference. Difference is subtraction. The difference of two perfect squares. This is a perfect square, but 3 is not a perfect square. So that's another reason why you can't factor this anymore. All right, Katie, give me one more.
She went to the bathroom.
Oh, she is gone. Okay. So here's what I want us to do. I want us to do page 429, and now I'm going to let you practice by doing the odd numbers. After you get done with them, okay, check your answers in the back, but will not do you any good if you don't. So let's do 1 through once you do 1 through 45, the odds, okay, you'll get lots of practice. Just like we did on number 22 and 40, first thing you say is, can I factor anything common out of them? Second thing is this a perfect square trinomial, or is this the difference of two perfect squares? Always look to see if you can do your little shortcut. And then if you can't, if you have something that looks like this, where, okay, this is a perfect square, but that's not a perfect square, then that's when you go back to factoring old school. List out your factors of 10. What numbers added together will get you a positive 4. Those are your two factors right there. The other thing is, what happens if this out front, oops, what if the coefficient out front is not a coefficient of 1? Can I do it easily like that and just list out my factors of 10? No. Then that's when I have to multiply the first coefficient times the last coefficient. That's negative 30. All right. A times C. Okay, what factors of negative 30 now will get me a positive 4? And you have to break this up. Oops, excuse me. You have to break this middle term up into new factors. All right. That is all I have for you guys then.